Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students, welcome back again to this TV learning series program. And I'm teacher Patrick, as I've said it several times. So today, as I said earlier, we will be continuing with the previous lesson. And you remember the previous lesson, we are talking about chemistry. And to be precise, we are looking at the identification of ions. Identification of ions. And this time we are just talking about the cations, because we have two types. When I mention the ions, one would maybe ask him or herself, and then if you see we are using the cations, then you ask yourself where are the other ions. So this time we are just looking at the cations. And the cations we are just going to look at, you remember in the previous lesson, we looked at the ions, ion 2 and ion 3. I hope you still remember even the reagents that we are using to distinguish those cations or to identify them in the lab. You still remember those cations or the reagents that we used? Very good. You remember we are using sodium hydroxide, we are using ammonia solution, we are using potassium hexacyanoferrate 2 and 3, and we are using potassium cycyanide. So those are the reagents that we are using. If you still remember, I hope you still remember even the observations that were made. So this time around, we are just going to look at, we'll have zinc ions, we'll have the copper 2 ions, we'll have the lead 2 ions. And as I've said, we have some other reagents that we are using to identify those cations. Some of them, as I said in the previous lesson, I said we have to carry out the preliminary tests, and then we carry out even what we call the confirmatory tests. So we have sodium hydroxide, we have ammonia solution, we have potassium iodide, and then we have potassium chromate. And when you look at these solutions, this one and this, potassium chromate and copper, there is some unique characteristic. If you can see, the unique characteristic that these two have is that they are colored. And if you remember what we mentioned in the previous lesson, we said these compounds here form colored compound. These elements here, the transition elements, they form colored compounds. So this one contains chromium. It has some chromium in it, which is also transition. This one contains copper, which is also transition. So that is why they look colored. The zinc look colorless for the reasons probably I hope you discussed them, because its d orbital is full, and therefore the splitting and the movement of the electrons can't give it the color. So let's right away start. Our experiment, and then we see how we can identify these ions for the purposes of precaution. So these are precautionary measures. I will just put on the gloves. I've put on the gloves. And then, because sodium hydroxide is corrosive, so I have to be very careful. And then put on these gloves. It can attack the skin, and therefore, I'm not saying I will not be careful. This is just, we don't take chances. So we are just going to look at copper 2 And then we start with sodium hydroxide. Right away, as we said earlier, as we were doing earlier in the previous, just pick some few drops of the copper. 1 or 2 cubic centimeters is enough. I said you don't need to use a lot of solutions. So you have to use few as you are doing this qualitative. Then we add some few drops, drop-wise. So you add 1 drop. 1 drop has already reached there. See what is happening there. There is a precipitate which is coming. I said, this precipitate looks jellied. So it is jelly-like. So it is, that's why sometimes it is called gelatinous. So we have to put excess. And shake a bit. The purpose of shaking is to see whether the precipitate disappears or the precipitate persists. So if the precipitate disappears, then we say it is soluble. If it persists, like here, if I put excess, so the precipitate here is insoluble. And this is what happens if we look at the copper 2 ions. So we started with the copper 2 ions. And then these copper 2 ions are reacting with the hydroxide ions from sodium hydroxide. And this gives the copper 2 hydroxide. So this is what formed here. The copper 2 hydroxide is formed here. That is solid. So the solid that is formed here, the solid is what we call the precipitate. This is pearl blue precipitate and is insoluble in excess. So we're just also going to look at the same copper with the ammonia solution this time. And then we see the effect. So we have ammonia here. So you're not so supposed to inhale that ammonia because ammonia has some choking, unpleasant, irritating smell. So it is wise to not inhale that gas directly. Few drops, as we said. Then you add some few drops of ammonia, drop-wise. So you have to first add 1 drop. Precipitate. It is also pear brew. See what is happening? Let's add excess. Very interesting color. Deep brew, almost coming to this one. This is what I was telling you. This is deep brew. When you look at them, I think there's some similarity in there. So this is deep brew. This is pearl brew. Some people sometimes they call it sky brew, but we don't have sky brew as a color in chemistry. So that's why I call it pearl brew, light brew. So in excess ammonia, this is what happens. Deep brew solution. But remember, it first formed the brew precipitate, which dissolves to form a colorless solution. So that is what happened. So with ammonia solution, you're having copper 2 ions reacting with the hydroxide ions. Remember, the hydroxide ions are coming from ammonium hydroxide. You remember ammonium hydroxide is the same as ammonia. So this one gives the copper 2 hydroxide. Remember when we added some few drops, if you remember very well, I can still repeat once again to see what I'm talking about here. So this is what happened here. This is the blue precipitate which formed first. And then this, when we added excess, you see what happens? Solution, that it must be, a solution has to be very clear. So it means that the copper 2 hydroxide, this pale blue precipitate, this is the same precipitate, now reacts with M excess ammonia. This forms a complex ion. So this is the deep blue solution. So as we add more excess ammonia, there is what we call ligand exchange. So the ammonium ions are also ligands. You remember what the ligand means? So the ligand ions are exchanged with the hydroxide ions and then turns into this compound. The deep blue solution we are talking about is this. This one, you remember the name? Can you give the name? Just write down the name of this compound. I hope you still remember. So this one is called tetraamine copper 2 ions. This is the name of this compound. So we can proceed to another one. Maybe you can go to lead and see what happens with lead. The same thing, so we have to add ammonia. So remember, before we go to lead, this is a confirmatory test. So the first one with sodium hydroxide is preliminary. So this second one is confirmatory. It is the confirmatory test with copper 2 ions. So we don't need to carry out some other tests. So let's see what happens with lead. And then we'll start with sodium hydroxide. Add some few drops. This is a colorless solution. Colorless solution, if you can see. And then we add sodium hydroxide. Just one drop has reached there. I think you can see what is happening. See the precipitate. I think everybody can tell the color of that solution. Oh, wow. The precipitate has disappeared. I don't know whether you are able to see that one. I can just do a repeat of that one again to see what happens. Some few drops. And then we add drop-wise, some few drops of, this is a precipitate. And when you look at this precipitate, this is white. I think it is very obvious. Then we add excess. More. The precipitate has disappeared already. That is a solution. That's the same, looks the same. That is colorless solution. So we say the precipitate is soluble. So we have had some precipitates which are insoluble. So the precipitate here is insoluble because it has disappeared. So we are saying this. So we have lead ions combining with the hydroxide ions from the sodium hydroxide, and this will give lead to hydroxide. That is the first precipitate that was formed. Then this lead hydroxide dissolves in excess. Lead hydroxide dissolves in excess sodium hydroxide. This and then forms, this is the colorless solution that has been formed. So this colorless solution is tetrahydroxyperambate 2 ions. So this is the colorless solution. Why? Why does it have to dissolve? And yet others were not dissolving in sodium hydroxide. Lead 2 hydroxide, remember, is amphoteric. Amphoteric means, what does it mean? Good. It means a substance that has both basic and acidic properties, or it can react with acids and at the same time react with the bases. So this lead hydroxide is amphoteric, so that's why it dissolves. It reacts with the sodium hydroxide again to form that colorless solution. So we are just going to look at the ammonia with lead again. So that was sodium hydroxide, so we have to look at the lead with ammonia solution, and then we see the effect. Remember, we said these are preliminary tests. So we have the lead, few drops, then add few drops of ammonia, precipitate. White precipitate forms excess of, I think you can tell already that this precipitate is insoluble. It's not trying to change. So it is a white precipitate. This is white precipitate. So here we said the white precipitate, the white PPT, dissolves to form a colorless solution. A colorless solution. Or you can say white precipitate, simply white precipitate, soluble in excess. So meaning that ammonia and sodium hydroxide give different observations. So let's do some other tests to confirm whether it is not only this one. We said we have to carry out some other confirmatory tests. As I said earlier, I repeat, these are preliminary tests. So let's do some confirmatory tests. We'll have to use the lead. Said add few drops. Don't need to add more. Then add potassium iodide. Add a few drops. Oof. See the color? Very interesting color. Deep yellow precipitate. See how it is? Oh. Deep yellow precipitate. And it is insoluble in excess. Deep yellow precipitate. So we have, when you use potassium iodide solution as one of the reagent, we are seeing that lead two ions. Now, the lead two ions here reacts with the iodide ions. The iodide ions from the potassium iodide, and then it gives lead to iodide. This is this yellow precipitate. Insoluble. So potassium iodide can be used to confirm the presence of lead ions in any solution. So if there is any solution that contains lead two ions, and then you add potassium iodide, this is what you get. So if you get this color, you confirm there is presence of lead two ions. So we can also, instead of using potassium iodide, we can also as well use potassium chromate. Potassium chromate, which is a yellow solution. Then we see what happens. We are going to add a few drops of a lead. That is a few drops of lead. And then you add potassium iodide, potassium chromate, which is here. Maybe one drop. See what is happening. The same observation is made with potassium iodide. See what happens? So here you have the lead ions reacting with the chromate ions. The chromate ions, and then you form the lead chromate. This is also yellow precipitate. So these two, either potassium chromate or sodium chromate, any solution that contains the chromate, when you add it to the ions of lead, then you have to get this very interesting yellow precipitate. So these two reagents, potassium iodide and potassium chromate, then this is potassium chromate, these reagents are used to confirm the presence of lead two ions. So let's go to, we have the zinc. So as we said earlier, the same, we'll have to do the tests with sodium hydroxide and with ammonia. So the zinc, these two solutions are enough to confirm their presence. So we have to add some few drops of zinc solution. This solution contains zinc too. Few drops. And then, drop-wise, we'll have to add sodium hydroxide. Sodium hydroxide. So we said drop-wise, you have to add a little. Are you seeing something there? Just take a very close look. See what is happening. There is something, gel, something forming. That's the precipitate. It is coming. Add some few drops again. You can add excess. There is no problem there. Of course, you have already added. See? Precipitate disappears. Colorless solution. Colorless solution is formed. So with the zinc, when you add sodium hydroxide, we are adding the hydroxide ions. The hydroxide ions, remember, are coming from sodium hydroxide. Then you'll get the zinc hydroxide. This is the white precipitate. The white precipitate, you remember we formed the white precipitate first, and then we added the excess. When you add the excess, so the zinc hydroxide combined with the excess hydroxide ions and then forms if you look at this, there is some similarity with lead. There is some similarity with lead. White precipitate formed. This was the white precipitate, if you remember. Then the white precipitate dissolves in excess, like this one, to form this compound. The same applies to zinc. So lead 2 hydroxide and zinc hydroxide are both amphoteric. So because of their amphoteric character, nature, that's why they dissolve in sodium hydroxide to form that complex compound. So let's carry out another experiment, and then we see what happens with the ammonia solution. This is ammonia solution. Ammonia solution. This is zinc. So as usual, we add some few drops. And then you add ammonia solution. Precipitate forming. You can add. Wow. The precipitate disappears as well. So here we have zinc. So there was first the precipitate. So the zinc ions reacting with the hydroxide ions. This gives the zinc hydroxide. And this zinc, that was the white precipitate which formed first. White PPT, you remember we formed the white precipitate. Then this zinc hydroxide now combines in excess ammonia. This will form a complex compound. A complex compound of zinc, which is tetraamine zinc 2 ions. Remember the one that forms with the ammonia solution with copper. This is tetraamine zinc 2 ions. So I'll just give you an exercise as we're coming to an end. I would like you to take note of the exercise. And next time, please don't worry. There are some cations that we have not looked at. We'll have to look at those cations as well. And then we carry out the same tests. So that marks the end of our today's lesson. Thank you so much for listening and for watching. We hope to meet again. Bye-bye.